Hello, welcome back. Today we're going to continue our discussion with implicit differentiation. We're going to take a look at a few different types of problems here. So buckle up. It's going to be a ride. So I hope we're going to have some fun. So for the first question we're going to take a look at, we're just finding the equation of a tangent line. So they already gave us the point, so all we have to do is find our slope. So to get the slope, of course, we're going to need our derivative. So I'm going to take my derivative here. Notice I'm going to start way over here. This is going to give us 3x squared plus 3, that's the weird looking y, plus 3y squared. Don't forget it's implicit, so we're going to multiply this by dy dx. Minus, and over here, I have a product rule right there. So we have to use our product rule. I'm going to use brackets here. Always use brackets or parentheses. I'm going to keep the 6 with the x. So my first function is just going to be the 6x times the derivative of the second, which is dy dx, plus the second, which is y, times the derivative of the first 6x, which is just 6. And that's going to equal 1. Simplify this. I am going to distribute first. So we get 3x squared plus 3y squared dy dx minus 6x dy dx plus 6y. This should be equal to 0. Not a 1 is a constant. Sorry about that. And that's going to equal 0 right there. So let's see here. Anything with the dy dx will stay. We're going to keep these. They all stay. And that's going to give me dy dx. And factor it out. We get to 3y squared minus 6x. And that's going to equal this negative 6y minus 3x squared. Therefore, my derivative, ran out of room here, we're going to get this negative 6y minus 3x squared over 3y squared minus 6. And there's my derivative. Wow, that's a lot of work just to get slope here, right? So to get my slope, our next question is just to take the derivative here, find the derivative at the point 1, negative 2. We talked about this notation yesterday. Just a way to write it out. Equals, plugging in everything, negative 6 times y, which is negative 2, minus 3 times x, which is 1, but square it, all over 3 times negative 2 squared, or y squared, minus 6. And let's clean this up. Of course, on top we get 12 minus 3. On bottom, that becomes 4. 4 times 3 is 12. 12 minus 6. So we get 9, 6. Or if you want to reduce that to 3 halves, you can. And now we write our line. Y plus 2 equals 9 over 6, x minus 1. And there's our tangent line. Easy peasy. All right. The next one, question number 2, is just asking us to evaluate a derivative. And again, what you notice here, we do have a product rule. So we got the first times the derivative of the second, plus the second y times the derivative of the first, minus 2 dy dx. And that's going to equal, again, our derivative here is just 0. Now, when I look at my dy dx's, remember, anything with a dy dx will stay. That's going to give us dy dx equals negative y. Whoops, forgot to factor out here. This is going to become x minus 2 equal to negative y. Therefore, our derivative dy dx, it's going to be negative y over x minus 2. Now, we have to be careful. It does tell me to evaluate my derivative at x equals 1. So notice in the equation here, down here, I need y. So I got to find y. Oh, look, I'm needy. There we go. Let me space it out a little bit. We need the y value. So I can find y by plugging it in. So let's go ahead and find y. Plugging it in, x is 1. So this becomes y minus 2y equal to 1, or negative y equals 1. Y is negative 1. And now I'm going to evaluate my derivative. dy dx, our notation that we learned, x is 1, y is negative 1, and I can just plug these in. Negative of a negative 1 over 1 minus 2, and that just becomes, let's see here, Top is just 1 over negative 1 or negative 1. And there's our value right there. And of course, we can even find the tangent line now if we want to. I could say y minus 1 equals negative 1. X, whoops, that should be y plus 1. X minus 1. There we go. Now, they're not asking for the tangent line, but, I could find it if I felt like it. Why not? Nothing better to do. All right, speaking of tangent lines, let's take a look at number 1 here. We want to write the equation of the line tangent. This is AP right here. Notice, I am going to need 2 points. I need to find y first. To find y, I'm going to plug my x in, and that's going to give us y cubed plus 2y equal to 3. And my guess is right now is that I made a typo and that this should be a square. So let's make this 3 a 2. Otherwise, we may not be able to answer it. I think I made a typo there when I wrote this out. Solve this, we get y squared plus 2y minus 3 equal to 0. We have to factor. Y plus 2, y plus 3, y minus 1 equals 0, and I get negative 3 and 1. So that's going to give me 2 points. I'm going to get the point 1, negative 3, and the point 1, 1. We're going to come back to these in a little bit. So I'm going to have 2 tangent lines here. So now we have to take our derivative. And this is where our product rule comes in. There's our product rule. We're going to get the first times the derivative of the second plus the second y squared times the derivative of the first, 2x. Plus 2, be careful, the derivative of y, dy dx, and that's just going to equal 3. This isn't so bad for us. So we're going to get, if I factor out my dy dx's, dy dx, this is going to become x squared plus 2. I can just factor those out. And that's going to equal 3 minus 2 x y squared. So our derivative, dy dx, 3 minus 2x y squared over x squared plus 2. There's our slope, our derivative finder, our slope finder. Now I have to find my slopes. I got the 2 points. I want the tangent line. Now I need to find my slopes. So my first one, I'm going to find the slope at the point 1, negative 3. Plugging this in, we're going to get 3 minus 2 times 1 times negative 3 squared, which is just 9. On bottom, I'm going to need x squared, well that's just 1, plus 2. So let's see what we get here. We're going to get 3 minus 18, which is negative 15, over 3, or negative 5. So there's my slope for this line. So actually I get my tangent line here too. Y plus 3 equal to negative 5, x minus 1. So there's our first derivative right there. There's our first tangent line. And then the next one, dy dx, but now we're at the point 1, 1. 1, 1. Just type that in. This becomes 3 minus 2 times 1 over 1 plus 2. So this becomes 1/3. So our tangent line here, y minus 1 equals 1/3 x minus 1. And there's our second tangent line. Piece of cake. Easy breezy, right? All right, go on to the next video. We're going to take a look at the second derivative and some other problems. See you then.